Okay, so like I mentioned in the previous video, tautomerization is the conversion between enol and keto tautomers, and this conversion can be acid or base catalyzed. In this video specifically, we are going to be covering the acid catalyzed mechanism. So we are beginning with our ketone on the left, reacting that with H3O plus and H2O to form our alcohol group and carbon-carbon double bond. Now, jumping right into that mechanism. So starting off by redrawing our starting material, including our lone pairs, and rewriting out our H3O plus. Now, oxygen is going to grab one of those hydrogens from the H3O plus. Electrons go on to, from that OH bond, go onto oxygen. And we now have a protonated oxygen that has a positive charge because it has one less lone pair than it would like. And now, due to resonance, we can take these electrons from one of the bonds making up our double bond and push those up onto oxygen, making it a single bond to oxygen, bonded to hydrogen, and that has its two lone pairs, so that makes it neutrally charged again. However, now we have a positive charge down on our carbon. What we can do now is we can add water. And in this mechanism specifically, there are two places that we could deprotonate from in order to form our carbon-carbon double bond. You might be asking yourself, which one is going to form? Well, let's walk through it. Let's form both of our products and see where we end up. So, going for this hydrogen on the left first. Let me draw that in green to make it a little more clear since my arrows are blue. Oxygen is going to swoop in, pick up that oxygen. Those bonds, or those electrons from the carbon-hydrogen bond, are going to be what forms our carbon-carbon double bond. So that would give us this form. Now we can also, we're just going to draw this because it's going to be the same thing drawn out right over here, just so we can see it. Positive charge. Now what if we deprotonated from this alpha carbon? Well, we'd still have water coming in. So that oxygen grabs on the hydrogen. Those electrons go up to form our carbon-carbon double bond. Okay, so now we have our two products. Which one is going to be more likely to form and why? Well, if we remember a couple things from our previous videos, substitution of alkenes matters. So, this one on the left that I have circled, we have a tertiary alkene. And the one on the right, we only have a secondary alkene. So our tertiary product is going to be preferred, or our tertiary alkene product is going to be preferred due to increased stability of that double bond. Now, I have a few practice problems for you to go through. Just kidding, I have one practice problem for you to go through. Try and predict the products and then work your way through that mechanism, and I will have answers posted for you to make sure you are on the right track. So thank you so much for watching. All right, this is the product that you should have gotten when This starting material undergoes tautomerization that is catalyzed by an acid.